What's up guys, welcome back to the channel. Today on this video we'll be doing the question paper that you see here on the screen. This is a national certificate for mathematics and 5. This paper was written on the 25th of November 2025 and it was an X paper that took 3 hours. So on this particular video we'll focus on question 4 of this question paper. Just in case you haven't watched question 1, 2, 3 videos, go to the description. I've left a playlist that contains those questions, and the very same playlist will pop up on the top right of this video. Click on that icon in order for you to watch those videos as well. So before we begin, I'm going to leave the timestamps on this video just in case you don't want to watch the questions in a sequence order. Again guys, before we look at question 4, I'd like to say thank you very much guys for watching, subscribing to the channel, commenting, and not forgetting those who like and share the video. Now that we're done with the introduction, let's look at question 4. Alright guys, here is our question 4. Now question 4, it is based on integration. If you can look at 4.1 there, they say determine the sigma y dx in each of the following cases. And it also has 4.1 and 4.2. All these questions that you see here are integral questions. So let's look at 4.1.1 and let's solve it. All right, here's our 4.1.1. Now, like I said earlier, that this question is supposed to integrate. So 4.1.1, we have y is equaling to, on the numerator, we have x open bracket 2 minus 3x close bracket divide by, on the denominator we have e to the power of 3x plus x squared. Now they also gave us a hint there. So the hint goes like this: let u equaling to 1 plus x squared multiplied by e to the power of negative 3x. So we need to use the substitution. So let me rewrite this question so that we can solve it. So when you rewrite this, rather include the sigma for now. Let's simplify the numerator there. Let's remove the brackets. If we multiply x with the 2 there, we're going to have 2x on the numerator. And x multiplied by negative 3x, we're going to have negative 3x squared. All this is divided by the denominator. You also need to simplify this denominator there. So we need to take out the common factor, which is e to the power of 3x. So this is where the trick was. If you take out e to the power of 3x, the first term there is going to be 1 plus the second term there is going to be x squared, but it never had e to the power of 3x, meaning you need to introduce e to the power of negative 3x close bracket. This means that if you multiply by this e here outside the bracket, it's supposed to take you back to that expression there on the denominator, right? I hope you guys can see that. So this here, we can write it as multiply by dx. There we go. Now that we are given a hint that u must be equaling to 1 plus x squared e to the power of negative 3x, we need to derive this one here. So if we derive this, we know that du over dx. Now the first term we have 1, it's a constant that is going to give us 0. We cannot do that one, we leave it. But the second term here, as you can see, this is a product rule. Just in case you don't know much about product rule, there is a video on product rule. I'm going to leave that video on the description. Go and click on that description, and also the very same video will pop up on the top right of the video that you're watching. Go and watch that video to understand the product rule. So the product rule goes like this: you derive the first one here, which is going to be our x squared. Let's derive it. It's going to give us 2x multiplied by, now you leave the other function, which is going to be e to the power of negative 3x, right? Always you plus them. Now you leave the first one, which was x squared, but this time around you derive e to the power of negative 3. So when you derive e to the power of negative 3x, this is going to be negative 3 multiplied by e to the power of negative 3x ln e close bracket. So as you can see, this needs to be simplified further. So let's simplify it further. So if you continue here, we can say du over dx is equaling to 2x multiplied by e to the power of negative 3x minus, because if you multiply with this negative here throughout, everything's going to be minus them. So we're going to be left with 3x squared multiplied by e to the power of negative 3x, because ln e is equaling to 1. Right, so this is what we have at the moment. So let's continue. Let me zoom down because we actually need this space here. So I hope you guys can see. All right, so when it's like this, we can write this like the following. We have du over dx. We can say 2x, and then since we have e to the power of negative 3x, we can rewrite this as e to the power of 3x on the denominator, minus, same here, we have 3x squared divided by e to the power of 3x. This here, guys, is exponential law, just in case you don't know much about it. Let me continue here at the top. We have du over dx, right? Now, if you can look at our denominator, is the same there. We have e to the power of 3x for both the terms here. So we can say all this is divided by e to the power of 3x. And what we have on the numerator, we have 2x minus 3x squared. There we go. So if you pay attention to this whole thing here, you will see that on our formula, we actually do have that derivative there. There we have 2x minus 3x squared divided by e to the power of 3, which is that. But this time around, it is multiplied by 1 plus x squared multiplied by e to the power of negative 3x. So how are we going to substitute that? First of all, let's make du subject of the formula. So du is the subject of formula, meaning we need to cross multiply this. We can say 2x minus 3x squared divided by e to the power of 3x multiplied by dx. There we go. So whenever we see 2x minus 3x squared divided by e to the power of 3x multiplied by dx, we must substitute it with du. So let's go back to this one. Now, if we set sigma, let me rewrite it in a way that can be easy for us to substitute. Open bracket, 1 over 1 plus x squared e to the power of 3x. Close bracket. Multiply. Remember, we were left with what here? 2x minus 3x squared divided by e to the power of 3x multiplied by dx. So this part here, let me highlight very quickly. This part here is the same as that part there. Let me highlight very quickly, guys. I hope you can see. There we go. It's the same. It's just that I separated them, but for the fact that we have multiplication, they can take you back to that question. Now let's do some substitution. Let's start with the one inside the bracket there. Let's say sigma. We have 1, there we go, divide by this here we said is equaling to u. If you still remember them, that is equaling to u. So we're going to substitute that with u. There we go. Multiply by all of this, which is that there, is equaling to du. So we can write that as du. There we go. Then we start integrating. Right. So from here, this is integral of ln. When we have something like this, we know that this is going to give us y is equaling to ln u plus c. But we know that u it's actually 1 plus x squared multiplied by e to the power of negative 3x. So we're going to say ln, instead of writing u, we're going to write this 1 plus x squared e to the power of negative 3x, close bracket, plus c. So this here is our final answer, right? Obviously, there are other ways of doing this, but since they gave us a hint to use 1 plus x squared multiplied by e to the power of negative 3x, substitution was the way to do this. All right, people, I hope this was not difficult. It seems so difficult, but if you knew your substitution, then it was going to be okay. So if you managed to understand this, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed. But if it so happen that this doesn't make sense, you go to the point where you got lost, rewatch it, and if that doesn't help, ask on the comment section, and I'll try to answer you to my level best. Right, people, we are done with question 4.1.1. Let's go and do question 4.1. 4.1.2. So people, here is our 4.1.2. So this question here, they want us to integrate this question here. So it goes like this: y is equal to cos to the power of 7x multiplied by sine to the power of 3x. So we need to rewrite this. So let's do it. We have to include the sigma there, and then let's put this inside the bracket. Obviously, we have cos to the power of 7x multiplied by sine to the power of 3x multiplied by dx. Right. So on this type of a problem, we need to change one of these trigonometric ratios so that they can be the same when we integrate. So let's rather change cos to the power of 7. Remember, we are simplifying, we are not integrating yet. You can say cos to the power of 6x multiplied by cos x, right? Multiplied by sine to the power of 3x, close bracket, dx. The aim here is to make sure that at least we have cos to the power of 1 there. Then when it's like this, we can change this cos to the power of 6 in terms of sine. But before we do that, let's first do the following. We can say sigma, open bracket. We can say open bracket again, cos to the power of 2x. Then outside there, we can say to the power of 3. If you multiply this exponent of 2 with that exponent of 3, they're going to give you the exponent of 6. So I hope you know this. These are exponents law. Again, just in case you don't know much about exponents law, I've made a video explaining the exponents law. So I will leave that video in the description. Go and watch that video just in case you want to understand the exponent laws. That video also will pop up on the top right of the video that you're watching. Click on the icon there and watch the video. Right, let's continue. So let me just write it like this for now. Sine to the power of 3x multiplied by cos x, and then we close bracket and then dx here. Remember, I said earlier, we need to change cos in terms of sine. So how are we going to do that? We need to use the square identity. So if we use the square identity, if you still remember, we have cos squared x plus sine squared x is equal to 1. So we can make cos squared x subject to the formula, which is equal to 1, and then transpose this sine squared to the right hand side. We're going to have negative sine squared x. There we go. So instead of writing cos squared, we can write 1 minus sine squared x. So let's do it. Sigma, open bracket. So we're going to open this one here. Instead of writing cos squared x, we're going to write 1 minus sine squared x, close bracket, to the power of 3, multiplied by sine cubed x multiplied by cos x, close bracket, dx. There we go. So we're still simplifying, guys. We haven't yet integrated. Right. In order for us to integrate this, we need to factorize this here because it has the power of 3. So the shortest method I can think of is the following. We can say 1 minus sine squared x squared multiplied by, open bracket, 1 minus sine squared multiplied by sine cubed x multiplied by cos x dx. There we go. Let's close the bracket like that. I hope you guys can see this. Let me create a little bit of space here so that you can see. So if you pay attention, this part here and that part there, when they multiply each other, they're going to give you this. So let's continue here at the top so that we can able to solve this further. So if you continue here, obviously we're going to write sigma there. So first of all, we have to factorize this one here inside them. So how are we going to factorize this? It's very simple. There is a shorter method that we can use to factorize. First of all, the method goes like this. You can say 1 multiplied by 1. It's going to give us 1 there. And then you say 1 multiplied by negative sine squared x multiplied by 2. This here is going to give us negative 2 sine squared x. And then we do the last one. We have negative sine squared x multiplied by negative sine squared x. This one's going to give us positive sine to the power of 4x, close bracket. But let's not forget, we still have 1 minus sine squared x again to the power of 1. Open bracket, 1 minus sine squared x. There we go. We still have sine to the power of 3 and also that cos x there. So let's write them. We have sine to the power of 3x multiplied by cos x multiplied by dx. So this here, you can put it inside the bracket like that. There we go. We also need to get rid of these brackets inside them. So let's continue. So sigma, open bracket. Now we have to multiply what is inside the bracket. So we're going to start by multiplying 1 with that one. Then we're going to get 1. We multiply 1 with negative 2 sine squared x. We're going to get negative 2 sine squared x. We multiply 1 with positive sine to the power of 4. So we're going to get plus sine to the power of 4x. Now we do the multiplication of negative sine squared x. So if you multiply this negative sine squared x with 1, it's going to give us negative sine squared x. There we go. If you multiply the very same negative sine x with negative 2 sine squared x, this here is going to give us positive 2 sine to the power of 4x. There we go. And then if you multiply the very same negative sine squared x with positive sine to the power of 4, this is going to give us negative sine to the power of 6x, close bracket. Let us not forget we still have sine to the power of 3 and also cos x there. So let's write them. Sine to the power of 3x multiplied by, let me zoom down so that we can able to finish this. We have cos x close bracket multiplied by dx. So from here we have like terms. So let's highlight the like terms here. We have negative 2 sine squared x and another negative sine squared x. Those are the like terms. And we also have positive sine to the power of 4 and positive 2 sine to the power of 4. Those are also like terms. If you continue, let me continue here. Sigma, open bracket, do this bracket like this. We have 1, so we're going to write 1 there. And we have negative 2 sine squared x and another negative sine squared x. They're going to give us negative 3 sine squared x. There we go. And then we have the following: positive sine to the power of 4x with another positive 2 sine to the power of 4x. So this is going to give us plus 3 sine to the power of 4x. There we go. And the last one, we are left with negative sine to the power of 6x. And we close bracket. Don't forget, outside there, we are also having sine to the power of 3x. There we go. Multiplied by cos x, close bracket, dx there. So we need to get rid of the brackets, meaning we have to multiply this sine to the power of 3x with everything that is inside them. Please do not multiply by cos yet. Sigma. If we multiply this sine to the power of 3, if you multiply it with 1 there, we're going to have sine to the power of 3x, and then we multiply it with negative 3 to the power of sine squared. This is going to give us negative 3 sine to the power of 5x. There we go. And then we multiply this sine to the power of 3x with 3 to the power of sine 4x. This here is going to give us plus 3 sine to the power of 7x minus, and then we multiply this sine to the power of 3x with negative sine to the power of 6x. That is going to give us negative sine to the power of 9x. There we go. Close bracket. So we left with what here? Cos x, close bracket, dx. There we go. So this here, guys, we can for now leave it like this, and then let's use substitution to solve this. So we can say let u equaling to sine x. Let's derive. If we find du over dx, what is the derivative of sine? It's going to be positive cos x. We all know that. So wherever there is sine, we substitute with u. But we are not done with this one here. We need to make du subject to the formula. If we make du subject to the formula, du is going to be equaling to cos x multiplied by dx. There we go. Now, before you continue, look at du. Du is equaling to cos x multiplied by dx. We actually have this here. on our equation, meaning this part here we can substitute it with du. So hopefully you guys can see that. Let me create a space so that we can able to continue. Right, let's continue. So we have sigma, there we go. So wherever there is sign, remember we substitute with u. So we have sine to the power of 3, this is going to be u to the power of 3, minus 3 sine to the power of 5x, this is going to be 3 u to the power of 5, and then plus 3 sine to the power of 7x, this is going to be 3 u to the power of 7, minus sine to the power of 9, this is going to be u to the power of 9, close bracket. Instead of writing cos x dx, we're going to substitute with du. So multiply by du like that. So when it's like this, it's easy for us to integrate. So let's integrate this. By the way, this is a standard integral. We are all good. So when we integrate, remember, we're going to equate this to y, and then we use the standard integral. So with the standard integral, it goes like this. You have u to the power of 3 plus 1 divided by 3 plus 1. There we go. Minus, we have 3, and then we have u to the power of 5 plus 1 divided by 5 plus 1. Plus, we have 3 u to the power of 7 plus 1 divided by 7 plus 1. And the last one, we have negative u to the power of 9 plus 1. It's going to divide it by 9 plus 1. Plus c. Let us not forget c to show that these are indefinite integral. So if you continue here, we're going to have u to the power of 4 divided by 4, and then minus, we're going to have 3 over, what is 5 plus 1? This is going to give us 6, and then we have u to the power of 6. There we go. Plus, we have 3 divided by, we have 7 plus 1, that is going to give us 8, and we have u to the power of 8 there. Then we have minus, we have u to the power of 10 divided by 10 plus c. Let us not forget that u is the same as sine x. Let's substitute it back. Let me create a space a bit. Let's substitute it back. So y is equaling to, wherever there is u, we have to substitute by sine. Sine to the power of 4x divided by 4. There we go. And then minus, we have 3 divided by 6. This is going to give us 1 over 2. And then u to the power of 6, that is sine to the power of 6x. There we go. Plus 3 divided by 8. And then we have u to the power of 8. That is going to be sine to the power of 8. Then x. And then the last one here, we have u to the power of 10. That is going to be sine to the power of 10 x divided by 10 plus c. Here is our final answer, guys. This here was long, so I hope you guys managed to understand it. Obviously, if you understood what was happening, it was not going to take you this long. Well, guys, here is 4.1.3. Now 4.1.3, they want us to integrate the following here. Y is equaling to cos pi over 2x sine pi over 4x. Now this here, guys, it's an identity. As you can see here, we have this identity on our right hand side. So this identity starts with cos A sine B. So we can say here on our problem, this here is A pi over 2x, and then this here it's B pi over 4 multiplied by x. There we go. So we can able to use this identity here. So let's substitute. Remember, we need to introduce sigma there. So if you look at this here, it's supposed to be substituted. We have half, right? And then open bracket, we have sine a plus b, but our a here, it's actually pi over 2x plus b, which is pi over 4x. There we go. Then we say minus, there is minus there, so we say minus there, and then we write sine, we have a minus b. There we go. So our a, it's pi over 2x minus b, which is pi over 4x, close bracket, and all this here is multiplied by dx. There we go. So from here, guys, we just have to add these angles and subtract them. So we can take out the half outside the sigma. Let's take it out, and then we left with open bracket sine. So what do we have inside the bracket there? What is pi over 2x plus pi over 4x? So what I'm getting here is 3 over 4 pi x. There we go. Then I close the bracket there, minus sine. So this one here, we have pi over 2x minus pi over 4x. So what do we have then? When I have 1 over 4 pi x. There we go. And this here multiplied by dx. So when it's like this, we are finished with simplification. It's time for us to integrate. So let's not forget that this we can equate it to y and say 1 over 2, and then we put the integral there. Now remember, when you integrate the trigonometric ratio, you divide by the coefficient then. So let's do it. So first of all, we know that the integral of sine is going to be negative cos. There we go. So we must include this here, 3 over 4 pi x. There we go. But then we need to divide by the coefficient of x there, which is 3 over 4 pi minus. Now, what is the integral of sine? Remember, the integral of sine is negative cos. We have to write the angles there. We have pi over 4x. There we go. Close bracket. And then we have to divide by the coefficient there, which is going to be pi over 4. Then close bracket plus c. There we go. So from here, we can say y is equaling to 1 over 2 open bracket. What we have here, we have a fraction which is 3 over 4 pi dividing this cos there. So when you have a fraction dividing them, this denominator must multiply there on the numerator, and you leave this 3 pi there. So when you write this is going to be negative 4 cos, then open bracket 3 over 4 pi. There we go. Divide by, all this is divided by 3 pi. Then we have minus and minus. This is going to give us positive. Again, we have a fraction which is pi over 4 dividing there. This 4 here is going to go on top there. Right, so this is going to be 4 cos, then open bracket pi over 4x, and then all this is divided by pi, because the pi there, it's remaining on top there. We close the bracket and we say plus c. Right, let me create a space so that you can able to see. As you can see, we still have the half there. You need to get rid of the bracket by multiplying with this half throughout. So if I say 1 multiplied by the numerator, let's start with this one here. It's going to be 4 cos open bracket pi over 4x close bracket. But then on the denominator, we have this 2 here. 2 multiplied by pi is going to be 2 pi. There we go. Then we continue. Minus, because this one here, it's minus. Then we multiply by 1 on the numerator. We have 1 multiplied by negative 4. This is going to be the negative 4 cos 3 over 4 pi x. And then divide by, we have 2 multiplied by 3 pi. It's going to give us 6 pi plus c. Do not multiply the c with the half. The half only affects the integral, not the constant. Now let's continue, simplify it further. If we simplify it further, we have 4 divided by 2. This is going to give us 2 cos open bracket pi over 4 x, and then we are divided with pi because this here is going to be gone, minus, and then we have 4 over 6. 4 over 6 is the same as 2 over 3, and then we still have pi there. Then we can say cos open bracket 3 over 4 pi x close bracket. So this here, guys, is our final answer. Let us not forget plus c. So this is our final answer, guys. Just in case you did not understand, you can leave a comment in the comment section, and you can always rewatch at the point where you got lost. Right, people? But if this helped you to understand how to integrate this type of a question, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed to the channel. We are done with this question here, which was 4.1.3. Let's go into 4.1.4. Alright guys, here is our 4.1.4. Now as you can see, we have a fraction here. This here is an integration of algebraic fractions. So we're gonna integrate this one here guys. Unfortunately, this one is gonna need us to use the long division method. So before we do that, how about we write it here on the screen? We're gonna put sigma there, and we have 2x to the power of 3 minus 5x squared plus 6x plus 12. All this is divided by x minus 4. Let us not forget it is multiplied by dx. From here guys, we have to use the long division method. So on this side, you're gonna write the divider, and then inside here we're gonna write the numerator. 2x cubed minus 5x squared plus 6x plus 12. Right, so the long division goes like this guys. First, you divide this 2x cubed with x. You're gonna be left with 2x squared there. So the next step is you multiply this x minus 4 with 2x squared. So if you say x multiplied by 2x squared, that is going to give us 2x cubed. And then you multiply this negative 4 with 2x squared, that is going to give us negative 8x squared. And the following step there is you subtract or add these. So these ones here inside the bracket, they will change the sign. You just multiply by negative. Now this 2x cubed becomes negative minus that 2x cubed. This is going to give us 0. This here becomes positive. If it becomes positive, just know that we have negative 5x squared plus 8x squared. That's going to give us plus 3x squared. Right, after here, we're going to drop this 6x. We're going to have positive 6x here. And then we drop this 12 here. We're going to have plus 12. Then from here, we repeat the same step again. We're going to divide this 3x squared with that x there. And then the answer is going to be plus 3x. Then the next step here, we're going to multiply this 3x with x minus 4. So what is x multiplied by 3x? This here is going to give us 3x squared. There we go. And then what is 3x multiplied by negative 4? That is going to give us negative 12x. Then we put this inside the bracket. We multiply by negative to change the signs. Right. So if we change the sign here, this negative 3x squared and that positive 3x squared, they're going to give you 0. So if you multiply by this negative 12x is going to become positive 12x plus 6x. That is going to give us plus 18x. Then we drop this 12. There we go. So we have the following now. So the next step here, we're going to divide this 18x with x there. And then we're going to have plus 18. So the next step here, you have to multiply this 18 with x minus 4. There we go. If you multiply this 18 with x minus 4, this is going to give us 18x. And then negative 4 multiplied by 18, that's going to give us negative 72. There we go. Now you have to put this inside the bracket and multiply by negative 1 so that you can change the sign. So let's zoom down so that you can able to solve this further. Alright, so from here we have to subtract and add this. So if you multiply by this negative outside the bracket, this 18x is going to be negative 18x plus 18x, that's going to give us 0. If you multiply this negative with negative 72, that's going to give us positive 72. And then if you say 72 plus 12, that's going to give us plus 84. So this is here is our remainder. So let's continue here. We can say the sigma of 2x squared plus 3x plus 18 plus 84 divided by x minus 4 and then close bracket dx. Right, just in case you don't know where these are coming from, this here 2x squared plus 3x plus 18 is what we got there as we are dividing them. And then this 84 there, it is the one there, and then divide by x minus 4, which is our divider there. So 84 is actually our remainder, just in case you did not know. So let's start integrating this. So before we do that, I think it's best for us to separate this, I can do it this way. I can say sigma 2x squared plus 3x plus 18 dx plus sigma 84 over x minus 4 dx. Right, so the fractions decided to do it separately. Now let's just drop it for now. We can say sigma 2x squared plus 3x plus 18 dx. Now we can take out this 84. Let's say 84 and sigma, and then we have 1 over x minus 4 dx. Then from here we can start integrating. So the integral of the first one here is going to be 2x 2 plus 1 divided by 2 plus 1. There we go. Plus we have 3x 1 plus 1 is exponent divided by 1 plus 1. And then we have plus 18x. Guys, when it's constant and we are integrating, we just multiply by the variable we are integrating with respect to. Plus, so let's look at the fraction there. We all know that we have 84 here, but this one here, the one of ln, so we can integrate this by saying ln x minus 4, and then the final it's plus c. So let's simplify it further. Let me create a space here, guys. You can say y is equaling to 2x exponent with 2 plus 1, that's going to give us 3 divided by 3 plus, and then here we have 3, we have the power of 1 plus 1, that is going to be squared divided by 2 plus 18x plus 84 ln open bracket x minus 4 and close bracket, that is going to be plus c. So here, guys, is our final answer. I know this can be challenging for most people because of the long division method, but all in all, this was straightforward for those who managed to do the long division method. Just in case this video helped you to understand this part of integration, do not forget to like, share, comment, and subscribe to the channel. But if you didn't understand somewhere, you can go to the point where you got lost, rewatch the video. If that doesn't help people, leave a comment on the comment section and I'll try to help you to my level best. Right, people, we are done with question 4.1.4. Let's go and do question 4.1.5. All right, let's look at question 4.1.5. Now we have the following expression. It goes like this: y is equal to 4x multiplied by cos 4x. Now this one here, guys, it's actually integration by parts, just in case you didn't notice. So with integration by parts, you need to know your priority list. Let me just write it here on the side. So this priority list, it goes like this: whatever that comes first is supposed to be f of x. So number 1 here, it's supposed to be ln x, and then 2, it's gonna be x to the power of nth, and then we have 3 there. This one is when you have exponential function. Guys, here's our priority list. It goes like this: the one on top always takes f of x. So I will explain it later as we continue. So the formula goes like this: for by parts, you will have sigma, right? And then you have f of x multiplied g of x prime dx. So what you should know here, guys, is that we're gonna have 4x multiplied by cos 4x dx. Guys, one of these must be f of x and the other one must be g of x prime. As you can see from the priority list, this one here, which is 4x, is the same as the second one on the priority list. So it means that it's gonna be the f of x because of the trigonometric ratio, it's underneath there. So if we have to name these ones here, we can say 4x is our f of x, and then cos 4x is gonna be g of x prime. So when we integrate this, it's gonna go like this: y is gonna be f of x multiplied by g of x minus sigma, and then this time around we derive f of x, and then we have g of x. There we go, dx. Right, so from here, let's use this formula to get our answer. Now the formula goes like this: it says the first step, you write f of x there. our f of x is gonna be 4x. There we go. And then we integrate g of x. Remember, g of x is prime from the equation, so the integral of cos, first of all, is gonna be positive sine, and then we have 4 there. But when we integrate, guys, the trigonometric ratio, we always divide by the coefficient of x, which is 4, minus, right, sigma. Now what do we have there? We have to derive f of x. So let's derive our f of x there. Our f of x is going to give us 4 when we derive it, multiplied by g of x. Our g of x is sine 4x divided by 4. So it's going to be sine 4x divided by 4 dx. There we go. So we have 4 divided by 4. This here, if you continue, it's going to give us x multiplied by sine 4x. There we go. Minus. We have this 4 and that 4, they will divide each other. So we're only left with sigma sine 4x dx. So let's continue. If we continue, let me create a space here. We have to integrate the last part there. When we continue, we're gonna left with y is equaling to x multiplied by sine 4x minus the integral of sine 4x. So again, the integral of sine 4x is gonna be negative cos 4x divided by 4, close bracket, plus c this time. So our final answer here is going to be x multiplied by sine 4x, negative and negative. This is going to become positive. And then we have cos 4x divided by 4 plus c. So here is our final answer, guys. I hope you managed to understand this one. As you can see, this is a by parts integral. So it required you guys to know the priority list. If you didn't know the priority list, then this was going to be challenging for you guys, and also the formula for by parts. But anyway, if this video helped you to understand how to integrate such problems, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. If you didn't understand, leave a comment at the point where you didn't understand. All right, people, we are done with 4.1.6. Let's go and do the last question. All right, guys, here's our 4.2. Again, 4.2, they are given as a statement there. They say determine sigma y dx by resolving the integral into partial fractions. So this here is actually partial fractions. Now, as you can see, there's a formula for partial fraction. Here they are. We have 1 and 2 there. But we're going to use this one for the question that we have there. Right, people. So be very, very careful. Do not confuse partial fractions with algebraic fractions. Right. So what must we do here? First of all, we need to factorize the denominator there. So let's do it. We can say x minus 5 divided by, we need to find the factors of x squared. I know it's x and x. There we go. And then the factors of 4, when we add them, they give us 5. It's going to be 1 and 4. When you multiply 4 and 1, you're going to get 4. But when you add them, you're going to get 5 there. Because everything is positive inside the bracket, everything must be positive. But all this is going to be equaling to, remember, we're going to use this formula here from the formula sheet. I hope you guys have seen that. So we can say A is equaling to, we're going to divide by one of the brackets there. It's going to be x plus 4. Then we say plus b is going to be equaling to, we divide by the other bracket, which is x plus 1, close bracket. What we need to do here, we need to make this expression here to be linear. So in order for this expression to be linear, we need to multiply by x plus 4 and x plus 1 both sides. So let me just create some space here so that I can be able to solve this. Right, so on the left hand side, we can multiply by x plus 4 and x plus 1. Let's not forget, we also have x minus 5. All this is going to be divided by x plus 4 and x plus 1. There we go. All this is going to be equaling to, open bracket, a divided by x plus 4 plus b divided by x plus 1, close bracket. Remember, we also need to multiply by the same x plus 4 and x plus 1. There we go. All these are divided by 1. So here we're trying to make this question to be linear. So this x plus 4 and that x plus 4 will divide each other. X plus 1 and x plus 1, they're going to divide each other. So on the right hand side, we're going to be left with x minus 5 equaling 2. Now this one here, we have to multiply each term with the outer part. If you multiply a over x plus 4, this x plus 4 and that x plus 4 will divide each other. So you're going to be left with only a and this x plus 1. So x plus 1, there we go, plus that plus there. And then we do the same thing. If you multiply b divide by x plus 1 with everything that is outside there, this x plus 1 and that x plus 1, they're going to divide each other. So you're only left with b with x plus 4. So x plus 4. Now it's linear. We can start working on it. So the next step here is to use the grouping method. So let's create a space so that we can able to do the grouping method. So the grouping method is very simple. You look at the x with the highest power here, especially on the left hand side. We know that x has the power of 1, which is the highest. So we say all the coefficient that are multiplying x to the power of 1, we're going to write them here. So on the left hand side, x to the power of 1 is multiplied by 1 because there's nothing there. So we're going to write 1 there. If there is any term that is multiplying x to the power of 1, we're also going to include it. So on the left, we only have 1 there. So we're going to say equaling 2 because this negative 5 is not multiplied by x. It's a constant, right? Then we come to a multiplied by x becomes a coefficient. So we can write a there. There we go, plus. And then we have b multiplied by x becomes a coefficient and it becomes b there. Then this one here becomes our equation. Let's make a subject of the formula. If we make a subject of the formula, we can transpose b to the left hand side. We're going to have 1 minus b is equaling to a. This here become equation 1. Right, now we group the ones with x to the power of 0 or constant, guys. C, right? So when you group like that, on the left hand side, we look for the coefficient or the constant. So when you look at the constant here, we have negative 5. So negative 5 is our constant because it's not multiplying by anything but just a number, right? And then this is going to be equaling 2. On the right hand side, we know that a multiplied by 1, this is going to give us 1. So it becomes a constant. So it's going to be a. And then if you multiply here, b multiplied by 4, this here is going to give us plus 4b. There we go. And this here become equation 2. So here, guys, it's another method that we use, which is grouping to find our a and b. So we can say substitute 1 into 2. There we go. So we're going to substitute equation 1 into equation 2. As you can see, equation 2 is negative 5 is equaling to a plus 4b. So wherever there is a, we're going to substitute with 1 minus b. Let's do it. So we can say negative 5 is equaling to, instead of writing a, we can write 1 minus b plus 4b. There we go. And then from here, we can say negative b plus 4b. This is going to give us 3b. And then we transpose this one on the other side. So if you transpose this one, this is going to be negative 5 minus 1. And then we left with negative b plus 4b. This is going to give us 3b. There we go. Negative 5b minus 1, that's going to be negative 6. And then is equaling to 3b. Right, let's create more space again, people. More space. So we divide by 3 throughout. So negative 2 is equaling to b. There we go. So if b is equaling to negative 2, we can find a. How? Let's go back to equation 1. Equation 1 is 1 minus b is equaling to a. We can say substitute b into 1. So here's our equation 1. Then we have 1 minus, instead of writing b, we're going to write minus 2 because b is equaling to minus 2. All this is equaling to a. So we can say 1 minus minus 2, that is going to give us positive 3. So A is equaling to 3. Now that we have A and B, we can able to go back to our equation and substitute them. So let me just zoom down for a minute there. We're going to substitute these values here. So we're going to continue here with the red pen. So we can say sigma. Instead of writing A there, we're going to write 3 over x plus 4. There we go. And then we go to the next one there, which is B. Remember, our B from our problem when we are solving, it was minus. So this is going to be minus 2 over x plus 1. Then this is going to be dx. So we need to simplify this further so that you can able to integrate it. So let me create a bit of space here. We can do the following. We can take out 3 and then sigma, we have 1 over x plus 4 dx, right? Minus. And then we take out 2 there. We're going to have sigma, and then we have 1 over x plus 1 dx. There we go. And then from there, we integrate. Y is going to be equaling to, we're going to write 3 there, and this is going to be ln x plus 4 minus 2 there. It's going to be ln x plus 1 close bracket plus c. So this here, it's how you do this one. This was actually type 2 of our integration, just in case you didn't know about it. By the way, guys, if this helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed, because we are done with question 4 of this question paper. It was a bit long, but it requires you to understand some basics before you continue with everything. But anyway, people, if you didn't understand, do not forget to leave a comment in the comment section. I'll try to explain you to my level best. Okay, people, we are done with question 4. Next time we'll be uploading question 5 of this question paper. So don't forget to hit the bell notification so that whenever I upload, you'll be notified. Thank you very much, guys, for watching. Till next time. Cheers.